Hello students, in today's class we shall discuss the STP conditions, NTP conditions and SATP conditions. Usually these conditions we use in the stoichiometric calculations and states of the matter. So people get confused between the STP and NTP, and sometimes we use the SATP conditions also. So let us see these calculations one by one. So first let us see the STP conditions. STP stands for Standard Temperature and Pressure. So here there are two types of the calculations in STP. So here we shall take the old calculations and new calculations. These new calculations we are using now in the NCERT. According to the NCERT textbook, these new calculations we are following. Now let us see both of these. Standard temperature. Temperature is always 0 degrees centigrade. That is the freezing point of the water. In both cases, temperature is 0 degrees centigrade only. But 0 degrees centigrade is not the SI unit, so that we have to convert this one into the kelvins. That equals to 273.15 kelvins. Here also 273.15 kelvins. Pressure. According to the old conventions, it was 1 atmosphere. Now new convention, it is 1 bar. And let us take the R value, 0.0821 liter atmosphere per Kelvin per mole. Since here pressure has been taken in the atmospheres, so the R value also should be in the atmosphere. And here R value equals, that is universal gas constant, whose value is equals to 0.0831 liter bar per Kelvin per mole. Now let us try to calculate the number of the volume occupied by the 1 mole of the gas in both conditions. So number of moles of the gas is equals to 1 mole in both cases. So let's try to calculate the volume. According to the ideal gas equation, PV equals to nRT, volume equals to nRT by pressure. So V equals to N means 1 mole, R value 0.0821 liter atmosphere per Kelvin per mole into temperature 273.15 kelvins upon pressure is 1 atmosphere. So let us try to cancel the units first. Atmospheres cancel out, mole also cancel out, kelvins also cancel out. So the final volume must be in the liters. So when you multiply 0.0821 into 273.15, it gives 22.4 liters, or it is also known as the 22,400 milliliters or cubic centimeters. That means 1 mole of the gas at STP, when pressure is 1 atmosphere, it occupies 22.4 liters of the volume. Now, new conventions. Let us calculate the 1 mole of the gas volume according to the new convention. So here also again, PV equals to nRT, volume equals to nRT by P. So volume is equals to N value 1 mole, R value 0.0831 liter bar per Kelvin per mole into temperature 273.15 kelvins upon 1 bar pressure. So bar cancel out, moles cancel out, kelvins cancel out. Final volume again in the liters. This volume is equals to 22.7 liters or else 22,700 milliliters or cubic centimeters. So whenever we are solving the questions, using the NCERT conventions in the NEET examinations, we must follow the 1 bar conditions. So we have to take the volume as the 22.7 liters, not the 22.4 liters. Now let us see the NTP conditions also. NTP stands for normal temperature and pressure. NTP and STP both are not same. They are the difference. There is a difference in the temperature values. In NTP conditions, temperature is equals to 20 degrees centigrade. When you add 273.15 to this, you will get the 293.15 kelvins. Pressure we take as 1 atmosphere. And R value, universal gas constant, 0.0821 liter atmosphere per Kelvin per mole. Again, number of moles is equals to 1 mole. And now let us calculate the volume of the gas at NTP, 1 mole of the gas. So volume is equals to again nRT by P. So let us substitute these values. N value 1 mole, R value 0.0821 liter atmosphere per Kelvin per mole, temperature 293.15 kelvins divided by pressure is 1 atmosphere. So again units cancellation. So volume is equals to 24 liters. So when we multiply this, that means 1 mole of the gas at STP conditions using the bar occupies the 22.7 liters of the volume. The same 1 mole of the gas at NTP conditions occupies the 24 liters of the volume. That's why now STP and NTP both are not same. And whatever, whether you are using the STP condition or NTP conditions, both are applicable only to the gases. These are not applicable to the either liquids or solids. Why? Because both liquids or solids are incompressible. So pressure effect is negligible then. So whenever you apply the pressure on either both liquids or solids, it is negligible. That is the reason why this PV equals 10 R, which is ideal gas equation. So that's why it is applicable only to the gaseous substances, not to the liquids or solids. Now let us see another type of the condition, that is SATP conditions. SATPs means standard ambient temperature and pressure. These are also known as the RTP conditions. That means room temperature and pressure. So this SATP conditions also, when you change the pressure, automatically the volume also changes. Now let us see here two conditions here also. Temperature, room temperature is 25 degrees centigrade, plus 273.15 kelvins. That value equals to 298.15 kelvins. And both conditions now let us take here also 298.15 kelvins. Here pressure we are taking as 1 atmosphere. Here pressure we are taking as 1 bar. So whenever you change the pressure, automatically universal gas constant R value also changes. So R value here it is 0.0821 liter atmosphere per Kelvin per mole, and here it is 0.0831 liter bar per Kelvin per mole. Again 1 mole of the gas, number of moles of the gas is always equals to 1 mole here. These all calculations are for 1 mole only. So when you apply the ideal gas equation, V equals to nRT by P. So volume, substitute these values here. 1 mole, 0.0821 liter atmosphere per Kelvin per mole. Temperature 298.15 kelvins, 1 atmosphere. So when I cancel all these units, so finally 0.0821 liters into 298.15 gives the value of 24.47 liters. Means 1 mole of the same gas at room temperature using the pressure 1 atmosphere occupies how much volume? 24.47 liters. And if you use the bar, volume equals to nRT by P. So volume, N value 1 mole, R value 0.0831 liter bar per Kelvin per mole, temperature 298.15 kelvins, 1 bar pressure. Cancellation of the units, so that volume is equals to, if you multiply these values, so you will get the 24.77 liters. Little difference is there. So all these conditions means when you are using the STP, here using the pressure as atmosphere, pressure as bar. What is the 1 mole of the gas occupies volume? This is 22.4 liters. This is 22.7 liters. Whereas NTP conditions, here it is occupying the 24 liters. SATP conditions, again 2 are there. Using the atmosphere, using the bar. When using the atmosphere, how much it is? 24.47 liters. This is 24.77 liters of the volume occupied by the 1 mole of the gas. So while solving the questions, we must aware that what type of the condition they are using. So if we have no idea about the conditions, and automatically we get the wrong answer. So using these values, I hope you get the correct answers while solving the questions. So I hope you understand this video, and if you have any doubts, please do write to the classroompoint@gmail.com, and please don't forget to subscribe the channel. Thank you.